I'm Anil Kumar, and in this video we will understand how to evaluate a composite function and also how to form a composite function, right? For f of x equals to 2 over x minus 1, where x is not equal to 1, and g of x equals to x plus 2, find g of f of 4 and f of g of x. So we'll begin with the very first one. And as you see, the domain has a restriction that it cannot be equal to 1, right? So we should keep a note on that. Okay. Now some of you can actually pause the video, answer the question, and then look into my solution. Now whenever you have a composite function, you should always start from inside out. So that is what it is. So you have to do inside out. That is the approach, right? So that means first you need to calculate what is f of 4. So first step is calculate f of 4. Now you're given f of x equals to 2 over x minus 1. So f of 4 means 2 over 4 minus 1, right? Replacing x with 4. So we get 2 over 3. So that is f of 4. Once you have calculated f of 4, you can rewrite your function. So the function was g of f of 4, correct? Now since we know f of 4 is 2 over 3, we can write this as g of 2 over 3, right? So that is how it should be worked out. That is what we mean by inside out. So this is the inside function we have to start with and then move outwards. Now g of 2 over 3 really means g of x is x plus 2. So you have to substitute 2 over 3 for x, correct? So that is equals to 2 over 3 plus 2. Taking common denominator of 3, we get 2 plus 6, and that gives you the answer 8 over 3, right? So we know g of f of 4 is 8 over 3, right? So that is how it should be solved. Now let's look into the next function, right? Now here to begin with, what I will do is I will write this function in two colors. We could write this as f of, within brackets, g of x, right? So we have g of x here. So inside out really means that you substitute the function into the function. That is what composite functions are, right? So you basically substitute another function, in this case g of x, inside the other function, the first function, right? So g of x is x plus 2, so we'll write x plus 2 here. You get the idea. So now you look at f of x. Now x actually has to be replaced by x plus 2, correct? So therefore we could now write this as 2 over, so instead of x I will write x plus 2. So we have x plus 2 and the function was minus 1. Do you see that part? So f of x plus 2, as you know, in function notation you have learned, you replace x with x plus 2. That is what you get. And now you solve this. So you get 2 over x plus 2 minus 1 is x plus 1. So that is f of g of x, right? So we should write this as equals to 2 over x plus 1, right? So that is how it should be done. Now whenever we are doing the functions, then what happens really is that the range of g of x becomes the domain. Now range also includes the value which is going to give us x equals to minus 1, right? So now in this function we have two restrictions. One we already had to start with on the function, which is x is not equal to 1, and the other one is x is not equal to minus 1. So we should write x is not equal to plus and minus 1. So now in this function you will realize that actually the composite function is 2 over x plus 1. Now if I put x as 1, in that case what really happens is that we do not really get minus 1. Do you see that? And therefore we could also think about domain as x not equal to just minus 1, right? Since this is a modified function, so in a modified function the domain also changes, right? So we have x as not equal to minus 1 as the only restriction in this particular composite function, right? So we can write our answer that f of g of x is equals to 2 over x plus 1, where x is not equal to minus 1. Okay, I hope that helps. Thank you and all the best.